everyone. I am Steve Revill from RISC OS Open. Thank you for joining about who RISC OS Open is, what we represent, and some of the things that we have been working on in the past, as well as some of the things that we will be working on in the future. So some of the things to look forward to. First of all, I just want to talk a little bit about our purpose. So RISC OS Open has been, since the advent of people working from home a lot, people not being able to go out and meet each other in recent years, that thankfully is starting to open up again. It put RISC OS Open team into quite a reflective mood, and we asked ourselves, what is our purpose within the community? What do we represent and what do we stand for? And it wasn't that difficult because we found that everyone had pretty much the same view, and that is that we are safeguarding the past, present and future of RISC OS for everyone. And what does that mean? It means we care about what RISC OS is, its place in history. We care about where it came from, and we're very interested in the preservation of that and the recognition of that. We're also very conscious that there are a number of different types of people involved in the RISC OS community, people who contributed in the past, people who use the operating system and the software, people who develop new software and add features to the operating system. And there's also the people who have yet to experience RISC OS, who may want to come into the operating system and try it out and learn about it. And from our perspective, we want to cater for the needs of all of those types of people in the community. And so we also care about making sure that as RISC OS is developed, it's not doing that in a way that causes a lot of problems for people who have older systems. So we have to think about this thing called backwards compatibility. We also care about forwards compatibility. So we're looking ahead to the direction of travel, to the things that will need to happen in the future, and making sure that anything that we do isn't closing the doors to what needs to happen in the future. So it's a bit of a balancing act. And the other thing to recognize is it's a voluntary organization. So RISC OS Open looks after what we do with the website and the development of the operating system as a spare time activity, and we do not pay ourselves for this. So although the company itself collects money from donations, we don't use that money to pay ourselves. So moving on, looking back to when we started this journey, we were incorporated in 2006, and we worked closely with a company called Castle Technology. And Castle at the time were the owners of RISC OS, and our mission very much was to work with them to find a way to open source RISC OS, to make it so that the source code was open for anyone to inspect and adapt and add to. Because previously RISC OS had always been a closed source operating system, which is basically a proprietary piece of software owned by a company that is very secret, and no one is allowed to really easily peer inside it and see how it works. So RISC OS Open had a mission right from the beginning to bring openness to the development of RISC OS. So working with Castle and subsequently moving with RISC OS Limited, RISC OS developments, we have worked quite hard on the journey over, must be 16 years now, to open source the operating system. So first we moved to what was called a shared source model, and then with RISC OS developments, we've been able to move it the next step. We've been able to move RISC OS to a true open source, which means anyone can download the operating system, anyone can download the source code to it, anyone can publish that source code if they wanted, and anyone can make changes to it. We try to orchestrate that, but it removes a lot of barriers to entry that developers in particular had. It was very difficult to convince people from the other operating systems, people who like to develop software, like the Linux system, there's a lot of developers there, tens of thousands of developers, and we had spoken over the years to quite a few people who would be interested in getting involved, but because RISC OS wasn't true open source, they saw that as a barrier. So we've been breaking down the barriers, and now they're no longer there. And hopefully we're seeing an uptick in people who are actually participating in developing the operating system. The other things that we've done, we have set up the RISC OS Open site, which pretty much everyone in the community is aware of. And this is the central focal point of where the community interacts. So if you want to download the software, if you want to get hold of the source code, if you want to talk about RISC OS and your experience with it, if you want to share your ideas for what should be done in the future, this is the place to do it. So I'm quite proud to say that it has become the hub of the community. We also have bounty schemes. So this is where we try and attract donations towards developing fundamental bits of the operating system that otherwise might be a bit too hard to do with people doing it voluntarily. So in many ways, it's connecting a developer who doesn't quite have the time, but if they could be paid, they could make the time, with the community who are hoping to see these features added to the operating system. And the bounty scheme allows us to specify what the features are, what they will bring, and why they're valuable. And then if people choose, they can put money towards seeing those things developed. And then as the total in a bounty increases, it might attract a developer to say, okay, that's enough to justify me spending the time it would take to develop that feature, and they can claim a bounty and then work on it. And we will talk to the developers behind the scenes, we'll coordinate with them, we'll ensure that they're confident and comfortable with what's being asked of them, and that they have a reasonable plan for how they're going to do it. And then once the features have been developed and they've been released to the users, that money that's in the bounty gets transferred entirely over to that developer. So we don't take a cut, it just all goes from the donations straight to the person who did the work. We have released 6 what we call stable releases of the operating system since we started looking after it. And that basically means all of the developments happening every day is considered the unstable or the beta version of RISC OS. So every night you can download a new version of it. And we like to have a milestone where we say that the operating system has reached a particular point where all of the main known bugs in all of the work that's been happening on it have been ironed out, and it's now sufficiently robust that on a particular platform that we're happy to release it to users as a stable release. And so if you're a bit nervous about getting hold of the nightly builds and playing with those, you can wait until a stable release is published and be more confident that if you then upgrade to that version, you won't be running into all of the potential glitches and funnies that you might find with the nightly builds. And there have been 6 releases, which are typically every 18 to 24 months is our release cycle at the moment. And we have, over time, we've been trying to promote RISC OS commercial software development as well. So there are still people in the community who are writing software that is sold commercially. Even though it's a tiny market, it's a valuable source of revenue for the people who do put their time and energy into writing these programs. And we have done deals with various authors to allow us to incorporate their software into special releases of software that we sell. And basically we carve up the amount of money made from that sale and pass it back to the people who contributed. So what this allows is for you to get hold of quite a large amount, a cross-section of commercial software, which otherwise would cost a lot of money, in a very small amount of money. So the Epic, for example, gives you the latest version of RISC OS, a whole suite of third-party software, and it's all for quite a low price, relatively low price. If you try to buy all that software individually, it would cost several £100s. So this is a useful way to get into RISC OS and to have a fairly rich experience with all the third-party software with very little effort and quite a little expense. And we have been working quite hard on our publishing empire, which essentially means taking lots of books that were published first by Acorn in the 90s and bringing them up to date. So we've been working through Acorn's catalogue of books and working with the community and with other tech authors to make sure that what's written in these books is fully up to date with what the current state of the art is with RISC OS. And we publish these either electronically or in printed format. So you can add to your bookcase, you can add the collection of printed books if you want to bring up to date the stuff you've got from the 90s. And finally, there's a few other bits. We've got development environments, which is all of the tools that a developer needs to help build new RISC OS software or to build the operating system itself. We managed to bring the cost of that down from several £100 to about £50, which, although it is still an amount of money for some development tools, it's a lot cheaper than it used to be, and it's a lot more accessible than it ever was. There's even versions of this for people, for example, who develop just in BASIC that are free. So we've got partnerships with other people who allow us to distribute the BASIC version of the DDE for free. And finally, we have talking to supporting the people who have older hardware, the people who have been with the community for many, many years. We make sure that our versions of RISC OS, that all the software we release is backwards compatible at least to the 7000 plus and the RISC PC. And the RISC PC is particularly important because for those people who don't have a native RISC OS computer anymore, for example, they might have macOS, they might have a Windows machine, you can still run RISC OS through an emulator, because all of the emulators that are available at the moment emulate the RISC PC. So it's very important to us to make sure that all of the software and RISC OS itself still runs successfully on the RISC PC, even though that computer is now over 20 years old. It's getting on close to 30 years old. So it's backwards compatibility needs to be maintained even today. So looking to the present, we have the nightly builds of RISC OS. Every night a new release with whatever's been changing throughout the day is published on our website, and you can download those, you can install them and try them out and feedback to us how your experience went. There's also a thing called packages, which basically there's an application called Pacman, which is RISC OS's native package manager. And if you run Pacman, you can easily find all of list of lots and lots of third-party software, and you can just click on one to install it. You can click on it again to uninstall it. It vastly simplifies the process of adding new software to your system. We have promoted. Let me skip ahead. We do promote and advise on the bounty scheme. So I said earlier, we do talk quite a lot to developers behind the scenes or even in public on the forums. We do try and help people to get engaged with the bounty scheme. We do try and help people as they are doing the work so that it progresses smoothly. And we have the source code, so anyone can go to our GitLab server and they can peruse their way around source code if that's their desire. They can learn how it works, they can feedback on the changes that others are making, and they can contribute their own changes. And it's all done in an open and structured way, rather than having submissions happening behind the scenes. So we want to make sure that there's nothing opaque about the process of someone feeding an idea, a new change to RISC OS through, and us accepting it and rolling it into the nightly builds. So some of the other things that are going on at the moment, we have RISC OS 5.3.0, the latest stable release of RISC OS is on the way. I don't expect you to read all of this tiny text. I'll just let you know that we have started compiling the list of the known bugs in the RISC OS unstable release, which is 5.29. And we've started building the definitive list of which features we believe need to be finished and incorporated into the next stable release. So the aim is sometime later on, towards the end of summer, maybe autumn, we're aiming to release 5.30. And there's a journey to go on between now and getting there. And part of that is to start publishing this information on our website and making sure that everyone's happy with what we're proposing goes in. The other part will be a traffic light scheme where we say for all of the major platforms like the Raspberry Pi or the Titanium, we'll say what the status is of RISC OS 5.30 on that platform. So basically, we're going to freeze 5.30 as a release candidate, and we're going to keep releasing release candidates for all the different platforms. And we're going to have a very clear tracker that says how close is that particular platform to being what we deem as stable. And if we don't think it's quite stable yet, we'll be very clear about what is holding it back. So anyone who's involved in maintaining a particular platform, whether it's IMX6 or the Raspberry Pi, they can help ensure that they've addressed those outstanding issues. And hopefully by the time we get to about the end of summer, all of the traffic lights will be green and we will be able to push the go button on RISC OS 5.30. So the other thing going on in the background, we have some work here on the ABC, which is the compiler for BBC Basic. And this allows it to use native hardware acceleration of what's called vector floating point. So if you use floating point numbers in your basic programs, you'll find ABC can now compile your basic program and it will run very, very fast compared to how it used to run. So I have a little demo here, and hopefully this will come across. But what I'm showing you here is the classic Mandelbrot fractal. So it's a little basic program. You don't really need to read it. But one thing I'll just explain is it's basically a series of loops. So it's some code that does something and then it goes around and it does something again. And that's inside another loop. It's inside another loop. There's quite a lot of things going on inside of plotting this fractal. And there's quite a lot of maths happening. And the maths is all floating points. So if you run this program in normal basic, what typically happens is it uses what's called the floating point emulator, which simulates the floating point maths that used to happen on old computers like the RISC PC or even earlier. And the floating point emulator is quite slow, as you can see here. If you can stay conscious while this demo is running, it's drawing a fractal, but it's drawing it rather slowly. This is basically as fast as it can go, doing all those loops with all that maths. And the new feature that we're adding to ABC and that we're publishing, and you can get hold of this for free, by the way, is to add vector floating point. So modern hardware, modern ARM chips have this thing called vector floating point maths, which takes all of that floating point and it runs it in the chip. So it's not trying to do all the maths the slow way, it's doing it very quickly. So just for the purposes of this demo, we'll take exactly the same program and we'll run it through the latest basic compiler. So if I switch it over to vector floating point maths, so what it's going to output now will be VFP. We'll take the program we just ran, we'll drag it over to the compiler, and this will compile it. It doesn't take very long. As you can see, it's just created the compiled code just like that. It took a few hundredths of a second. And then if we run the compiled code, this is going to do the same maths, and that's how fast it runs. So if your program runs vector float, if it does any floating point maths, hopefully you'll find that this is a useful new feature. And there's a guy in France called David Fuigi. I'm sorry about the pronunciation. He has teamed up with RISC OS Open to release a cut down version of the DDE, the development environment, which includes ABC, the compiler, and it's entirely free. So if you want to go and Google him, have a look, and if you want to have a play with that, feel free. So moving on, we have a couple of toolbox widgets, which are for, again, this is for programmers who like to write desktop applications. There's a couple of widgets called Tree View and Tabs, which are, they've been around for a long time, but we're incorporating them into the RISC OS source tree so that they're part of the core of the operating system and everyone can just count on them being present all the time. And they're quite useful because you can get this sort of collapsing tree view of some hierarchy of things, whether it's a filing system or something else. And there's the other one that's very common in user interfaces is having these tabs where you can click between different tabs in the user interface. And that becomes very easy to do in your toolbox applications using these two gadgets. So we're taking someone else's code and just changing it to fit in with the rest of the operating system, and therefore it will be part of RISC OS going forwards. Okay, networking, we're also working on one of our bounties, which is to update the network stack and bring it into this century. This is a slightly different approach to the way RISC OS developments have approached the problem. So these two things are different, but they're achieving some similar objectives. So we're aware that RISC OS developments have been doing work on the network stack in parallel with ourselves, and we talk to RISC OS developments on a regular basis. So every effort is being made to make sure that these two pieces of work don't diverge and work together as much as possible. But one of the things we are doing is we're publishing a beta release of some of the tools related to the new network stack. As the bounty progresses, you'll be able to play with these and give us some feedback and tell us how it's looking. So one of the things I'd like to do is make sure that we communicate with everyone and tell them exactly what we're working on with this bounty, give the whole community regular updates on what we're doing, why we're doing it this way, where we're aiming to get to. And this will be coming along with the beta release that you'll find on our website. Also, another video. This is again quite aimed at developers again, but the source code is on the RISC OS site in GitLab, and Git is a very popular tool for developers now. This is how you manage source code. There's a few competing technologies like Mercurial and Git, but Git has become pretty much the de facto standard. And the problem with Git is there's never been a way to easily access sources that are in Git on RISC OS itself. So you've always had to revert back to a different operating system, be it Linux, Windows, or a Mac, to access the source code properly and to interact with it. And that's changing because one of the bounties we've got is to bring a native Git client to RISC OS. And one of the stretch goals, which is actually progressing as well, is to give it a user interface. So you're not just typing in a command line. And in this demo, we're just basically showing you how it works. So if you're not into writing software, you can tune out for a minute. But if you are, hopefully this is useful. But what it does really is you will typically say which is the component you want to work on. You can create a directory, an empty directory, and then you can go over to our website and you can say, I want to clone all of the source code related to this particular component from the website onto my local machine. And all you have to do is tell Git to clone it. You have to tell it where you want to get it from, which is our GitLab server. And you have to say, where do you want it to go, which is your new empty directory you just created. So this is what I'm doing here. And it's going to sit here and think for a little bit. And then once it's finished thinking, it will download all of the source code. I'll just fast forward a little bit. Here we go, download all of the source code. And now if we open the folder and look inside, that's all the source code for the build system, Pling Builder it's called. Now if I drag it down to this user interface, and you can tell it's a prototype because it's got a blue square as its icon, not very imaginative. You can see this is the source code's history for that component. It says everything that's happened to that component, when did it happen, why did it happen, what was the comment put on that code when it's changed, and what were the files that were affected by that change. So you can see Jeffrey Lee did this. When did Jeffrey Lee do it? There's the date and time. What did he say he did and his explanation of the changes he made, and which files did he touch. So you can now look at any part of RISC OS and you can easily see what's changed, when it changed, who changed it, and why they changed it. So it's extremely useful tool for RISC OS, and it's coming on in leaps and bounds. So hopefully very soon now we'll be getting close to the point where we'll be able to release the new Git client for RISC OS. And finally, I'll talk a little bit more about the future. So the things that are to come with RISC OS. So that we've identified 6 headline big ticket items that we think are interesting to all users really. And one of them is to make RISC OS work properly on multiple monitors. So there's some software in the past called Geminus, which did this to some degree. but we want to make it a native feature of the RISC OS operating system. So there's thinking and there's some work in progress to allow us to understand how are we going to do this in a way that's flexible, that doesn't cause lots of problems to the people using the operating system, and just happens as fluidly and naturally as possible. And I think most people on other systems are just used to this as a normal way of working. If you plug a second monitor into your laptop, you expect it to just work. And we would like RISC OS to operate in the same way. We also want to make some changes to BASIC, so we don't want to change it in any non-backwards compatible ways. That's very important, but we do want to add some modern features. And one of the features that's particularly in the frame at the moment is structured data types. So there's quite a lot of thinking happening, and we've been talking to people closely related to BASIC in its history. I worked on BASIC back in the Acorn days, but we've also been speaking to a few other people like Paul Fellows. We've pinged Sophie Wilson about it as well, who's the original author of BBC Basic. So we're making sure that all of the people involved in it who we think are key players, we're making sure that we're consulting with them and going to share all of our ideas of how we take BASIC forwards as a language. We're also looking at what's called large physical address extensions, and all that basically means is allowing you to have lots more memory in your RISC OS machine. So at the moment you have limits, hard limits on how much memory there can be in a RISC OS machine, and we want to make sure that we are looking ahead. So it's easily possible to get machines with 32, even 64 gigabytes of RAM. RISC OS would really struggle to work properly on that. So there's significant under the hood changes would need to be made to support that. And that's one of the things on our big ticket items that we're looking at. Another thing is making sure RISC OS can run efficiently on multiple core processors. So even on a Raspberry Pi, you typically have four cores in the processor, and RISC OS will be sat there twiddling its thumbs on 3 of them. So only one core is doing all of the work. So as modern processors have more and more cores, you're not getting much value out of that with RISC OS at the moment. It's only running on one of them. And as that's the way computers are typically getting more and more powerful, we're not seeing RISC OS getting correspondingly faster and more powerful on newer and newer hardware. It's still bottlenecked by only running on one core. So there is work in flight at the moment to make RISC OS work more effectively on multiple cores. And it's quite hard. The vector floating point work is ongoing. So there's other areas of the operating system where we want to see this supported, because I think you can see from the Mandelbrot demo that it's very useful. It's certainly for particular classes of program, they will run much, much faster on modern hardware. And finally, we've got 64-bit addressing, which is essentially modern ARM processors are increasingly moving towards what's called 64-bit architectures and away from the old 32-bit architectures. And RISC OS is very, very much hard-coded to run on 32-bit architecture. So it will not work out of the box on a 64-bit processor. We're increasingly seeing a trend where the 32-bit support on modern processors is going away. So there is a point, a time horizon in the future that's getting nearer and nearer, where you'll buy a machine, it will have a 64-bit ARM processor in it, and it won't be able to run RISC OS at all. So this is a problem, quite a big problem, and it's going to involve a lot of work to sort it out. And there's quite a lot of different directions we could go in to address this issue. And we're working with various people to identify which the best direction of travel is for the operating system. So what we don't want to find ourselves in is another hard stop where, like with 26-bit to 32-bit, RISC OS was facing the same sort of existential crisis back in the days of going from the RISC PC to the strong ARM RISC PC to the Ionics. So there's quite a lot of work to be done, and a lot of it is under the hood, but it's important to the future of the operating system. And really, that's it from me. So I'll open the floor now to any questions that you might have.
A quick one, Steve, thank you very much for the presentation. A quick one about the BBC Basic enhancement. Recently, I've been working with BBC Basic after, I don't know, 25 years.
Yep.
And one of the biggest problem I had was that the software I was creating, I wanted it to run on RISC OS 3, 4, 6, and 5, of course. So will this new BBC Basic be made available also for older RISC OS as an external module or something?
Yes.
Oh,
yes.
brilliant.
So it will be soft loadable.
Yes.
The same way RISC OS currently is, Basic is on the RISC OS. I think at the moment, if you load Basic Trans and Basic as modules, you will get all of the modern features. The same is still the intention for this. One of the things that we are looking at, though, to kind of make this giant leap is that adding new features to the language is quite hard because it's quite tightly written ARM code. And one of the first things I did with Basic when I was at Acorn, and I inherited it from Sophie, was to rework all of the source code so I could understand it because it was very much written in a way that only Sophie understood. So I had to add lots of comments. I had to add a lot of white space so I could pull it all apart and then get my head around it. It's quite complicated. So something we're looking at, and it crosses over with the 64-bit future, is translating the code itself, the Basic module, into C. So instead of it being written in hard-coded assembler, we're looking at rewriting Basic in C, which is a big and difficult step, but in many ways it's a baby step compared to the broader job of getting RISC OS itself to run on 64-bit.
Understand, but wouldn't it be, I don't want to suggest you guys what to do because obviously it's not my place, but wouldn't it be better just to make sure that all the syntax supported by BBC Basic is retained, but the implementation in C is not a conversion of the ARM1? That will be quicker because this is...
That's exactly right. That's very much a way of doing it. And I think what we attempted to do is a competition between both approaches, because we have been speaking to someone who's very good at writing reverse engineering software, and their day job is basically writing quite sophisticated software that translates assembly programs into high-level languages. I think Basic will be quite a challenge for that because I know how it works and I know how tightly coded it is. So it'll be very interesting to see how maintainable and good a machine translation from assembler into C really will be, or whether it's easier to just do a clean room C implementation that maintains the syntax and semantics of the language and then build on that. Either way, it would be quite fun to run both of those in parallel and see which one turns out to be the best to use as the basis going forwards.
Thank you very much. I did have a look at the source, and there are a lot of pieces where the code reuses itself. So my personal opinion is it's going to be very... It will not work in C.
I think it would be very hard indeed.
Yeah.
I am deeply suspicious that whether it's possible at all. But I think it'll be quite a quick exercise to find out the answer.
Yeah. It's always worth it. It's always worth it. Thank you very much.
Thank you. Any other questions? I'm seeing comments, but I'm afraid I'm not catching up yet. So let's have a look.
What will your work on a new network stack offer that what RISC OS developments have done, isn't pretty much already there from theirs? Yeah.
So one of the things is making sure that it's all fully backwards compatible with systems like the RISC PC, the A7000 Plus. Another thing is looking at all the related applications, the tools that it uses. We want to make sure that we've updated all of those. We want to make sure that the TCP/IP libs library is updated to support the new network stack, so that third-party software that's already using the TCP/IP libs doesn't need to be completely rewritten to use a different library. And we want to make sure that we don't have any unnecessary glue layers to translate between the old way and the new way. We want to make it work natively. And part of that is by choosing to use the same original sockets implementation that the existing network stack uses. So there's a number of under the hood kind of fundamental design decisions and ways of operating that we've taken a different view on how you'd go about doing it. But in some ways, the end user experience might not be vastly different. So we'll see. But we're quite committed to the route that we're taking. The other thing is that what we're doing right now is just a step along a longer journey. This is one that we've published for quite a few years now, and the longer journey involves opening the door to things like native Wi-Fi support and Bluetooth support, which are the next steps. And our way is a progression towards easily adding those features, where I think the RISC OS developments route is very self-contained in being an IPv6 type implementation. So that is not part of a bigger, broader mission. It's solving a very specific problem for RISC OS developments, because I think it was initially, it was sponsored by one of their clients, a commercial venture that had a particular need, which was related to IPv6. So in a way, the work that RISC OS developments is doing, it's more, the fringe benefit is that some IPv6 support is coming to RISC OS, whereas our approach, we're looking at what does a completely holistic view of bringing all of modern networking and protocol support to RISC OS look like, and getting there in a step-by-step manner. So that it feels like quite an opaque answer, but unfortunately it's because it is quite technical. I'm hoping the way we're going is just a small step in a much bigger journey that delivers a lot more value than just what's to most end users, if you look at IPv6, is not that much use at all. Because IPv6 on its own to a home user is largely irrelevant.
Thank you.
No problem. Thank you. Just reading through comments very quickly. Not sure I can see anything that's a question. Yes, there was an observation about Richard Russell's work around structures in BASIC. Yes, we're aware of that. We're aware of BBC Basic for Windows. We're aware of Basalt. We've looked at Visual Basic. We've looked at Pascal and Python. We're being inspired and influenced by a lot of things. And we're hoping to share our ideas publicly before we go forwards and write any code. So rest assured, we're not planning on changing BASIC without having consulted. Or a couple of questions. I saw one on the chat. Do we have a schedule for things like the large memory support? So of those 6 big ticket items, I'm afraid we don't have a roadmap, and we don't have an ETA for any of these things. They're just what we perceive as huge topics, huge exercises that we need to help with the coordination of. So for the most part, the people behind Rule, the team here, we don't have the time to do these things ourselves at all. So we have the time to do little bits and pieces of them, but we really look to other people to help with doing the heavy lifting. And for the most part, these are man years worth of work doing these big ticket items. So we're coordinating, we're chivying, we're trying to turn them from where they are as conceptual problems into things where there's a plan. But really, it needs the manpower to be assigned to the plan before you can start guessing when the end date might be. And for the most part, we're quite a way away from that on most of these. One of the things that is making some really obvious and useful progress is the work that Jeffrey Lee is doing. I think he's doing bits and pieces on multi-core support, and every now and then you'll see something coming out of that shows that he's making some forwards progress. Another thing that you might see, hopefully fairly soon, is our proposal of what we're going to do with the basic language to extend it to add structured data types. So what we'd like to do is release a document that describes what the proposed language changes will be. But as to saying when the actual changes would happen, that's a big unknown, because that involves finding someone who's going to do the work. I'd love to do it, but I think it'd take me about 6 months, and I'm not sure how I'd pay the bills for 6 months.